And welcome back. Now the Arduino on my desk here is looking a bit lonely today, isn't it? But that's because it's there simply to give us a helping hand by putting stuff out through the serial port so we can see what's going on. Yes, we're going to look at Printf for Arduino. Now this is really aimed at beginners because in the Arduino world, with those people writing Arduino speak, Printf doesn't exist. You have to use Serial.print. Yeah, okay. A few weeks ago we did a video about how we can get rid of Serial.print statements cluttering up our code and have them switched on and off, and that's great, and I hope you're all using that. I mean, I use it all the time. Reduces your program size and speeds up the execution because stuff's not being thrown over the wall to the UART. Great. But this particular video is all about how we can format the stuff on the output stream without having all these ridiculous Serial.print statements. Let's have a look to see what I mean. If making a PCB is a bit of a puzzle to you, let JLC-PCB help you put all the pieces in the right place. EasyEDA is an intuitive electronic design tool, just as I'm showing you here. And when you've done that, you can convert it into a PCB like this one here. And you can view it in 3D and see exactly how it's going to look before you order it. It's easy to order from JLC-PCB directly from within EasyEDA, with fast, reliable deliveries, and now $2 for 5 pieces, including aluminium boards. They can even assemble them for you at no extra charge. Why don't you see what JLC-PCB can offer you today? So let's bring up the code window. I've just written this sort of noddy script really just to show you what Printf is all about and why it's better than Serial.print. Right, this is the code. Now I've made this a little bit bigger, this code window today, because a couple of people mentioned a while back that they were having troubles viewing it on their phones, and to be quite honest, never did I think people would be watching my videos on phones, but there we are, just goes to show, doesn't it? Okay, so what we've got here then is just a little bit of blurb at the top, you know, just to let you know what's happening. We can read that at some time in the future. Okay, right, so let's start at the beginning. The first thing you need to do is include this library here, libprintf. Now you can download that from over here, Arduino Printf. You can see the oh, you can't see the line. Oh, where's it gone? Oh, the address line is just there we are. There's the address line. Look at that. Okay, that's the Arduino Printf. Just download that, unzip it, stick it in the libraries folder, which is undoubtedly a subfolder of your sketches folder. Right, just put it in there and it will find it. That's not a problem. Okay, right, back to the code. Right, we'll assume that your libprintf library is installed, and right, here are some values that we're going to use as part of our little test. Okay, so we're going to have an integer value of 42. A long value of 1,000,000, a float value of, well actually I've put it down as a double now, I was playing about, which is pi of course, 3.1415926, and a boolean value. These are the sort of things that you might well want to print out as part of your serial debugging statements, yes? So how would you normally do this? Like, let's take this one step at a time and go, right, I've got these values, they're in some function somewhere, and I need to print them out. Let's have a look. Right, so we're in the setup. We still have to do the standard serial.begin. You can't get away from that. That does set up behind the scenes, you know, the baud rate and switches the UART on and whatnot. Now you can, of course, still use serial.print or printline wherever you want. You don't have to use printf. Okay, so if there's some particular reason why you want to use serial.print still, you can. Nobody's forcing you not to use it. But let's see, how would you print then this line here? Look, starting from there all the way to... Oh, well, it's sort of gone off the screen a bit. Let me make that window a little bit bigger. There we are. Right, so what we're saying is you want to print out, as part of your debugging, iteration 42 has a value of 1,000,000 derived from that pi number, 3.1415926. Okay, how would we normally do that? Well, as it shows here, we'd have several print statements. There is just no easy way around that in the Arduino speak world. Yeah, so you'd have serial print, the string, not forgetting the space at the end of the word. Yeah, how many times have we all forgotten that? Then the value, then another bit of a string, and then another value, and so on and so forth. Yeah, great. Okay, so you do all that to get that one line out, and it works. Yeah, it does work. And you believe me, when I started with the Arduino, I was using this all the time, but I was a little bit, well, I was a bit bewildered really why we couldn't use printf. Now, for those of you in the ESP32 world, you have printf. And if you haven't used it yet because you've not realised that ESP32 and the 8266 has it built into their framework, well, by watching this video you're just about to use it and you won't need to download that library. Yeah, it's all part of it. Okay, so what have we got here then? We've got these multiple, how many have we got? 1, 2, 3, 4, 5, 6, 7 lines. Wouldn't it be nice if we could just print that using one printf statement? Right, I'm just going to bring up the debug window, serial monitor. Okay, just see what this looks like though in this form here. Okay, right, so that runs and it says, well, setup complete first because we've said setup complete here, so that's the first line out. And the second line is all those bits and pieces all strung together in a single, oh hang on, that's interesting. Look, the pi value, which we've stored as a float, or a double in fact, has come out as 3.14. Maybe there's something we can do as part of the Serial.print to make that longer, but frankly I don't use floats and you shouldn't either. Let's get this quite clear. Floats are the devil's spawn. I mean, they just are not accurate. It's you know, let's not go there. Floats and doubles, not worth it. If you need to hold a value like, well, like this one, 3.1415926, it'd be better to hold it as a long or something, so complete integer, and then at the point where you need to see it with a decimal point in place, then output it as a float, and only then, because otherwise you're going to get inaccuracies all the way through. Believe me, been there, done that. Right, let's move on then, move away from Serial.print and see what the next line says. Right, I've jiggled around the window sizes so we can see what's going on, because some of these lines are quite big. Okay, so the printf syntax is as it shows it here. So we say printf, you have the string in quotes like that with place markers throughout the string where you say a value will appear here and another value will appear there, and you tell it what type of value. So in this line I've highlighted here, look, we can say iteration %i because it's an integer. You can put %d in there, by the way, if you want to. Has a value of %li, it's a long integer, right? Derived from %f, float. Okay, great, okay. And then you say, oh yeah, don't forget this bit at the end, /new line. Printf will not put a new line on it. A bit like Serial.print might. You have to say serial.print line, don't you? Well, there is no printf line, so you always have to put the /n at the back. And of course, once you do it once, you'll never forget it again. No, really you won't. The number of times I've forgotten to do it, believe me. But you'll soon notice it on the output. So don't forget your new line character at the end of the string. Sometimes, of course, you might not want a new line character. Yeah, we'll come on to that. Right, so we're saying then, iteration %i, this one, integer value, has a value of long integer, that is my long value, derived from %float, and there's a float value. Great, which is pi. Yeah, so the long value is 1 million, and the int value is 42. As it says there, is the meaning of life, the universe, and everything. Hitchhiker's Guide to the Galaxy. Yes, I know there was a reference in a previous video I did about 42 and don't panic, and I said mainly harmless, and quite a couple of people corrected me. It's mostly harmless. Of course it is. What's that? I've never heard of it. You've not heard of Hitchhiker's Guide? Surely everybody has heard of Hitchhiker's. If you haven't, you're missing a treat. I guess that people who are interested in computers will probably appreciate this quirky comedy sci-fi stuff of Hitchhiker's Guide. So do yourself a favour and go and look it up on Netflix or Amazon or somewhere. It's a good one. The BBC one, actually, it was a series, was very clever. Anyway, after that you will certainly know where your towel is. Okay, so this is pretty simple syntax, isn't it? Yeah, we're just saying here's a string I want you to print. I want you to place various values at the point where these markers are, and here are my values. How does that then look on the output? Well, if I hit a key, because as you can see on the code there it says wait for key press. Yes, I can do this in real time. So if I hit the key now, there we are. Iteration 42 has a value of 1 million derived from, oh look, well, 3.141592. It didn't like the 6 at the end, did it? But at least it's better than the Serial.print with a standard float, yeah, truncated to 2 characters. And printf will only print out what you tell it. And there are obviously have got to be some defaults, haven't there? So with a float, it's saying there are only 6 characters behind the decimal point. But you can change that, and we'll have a look how to do that in a minute. But the beauty of this, I hope you're appreciating, is it's one line with all the values you want to print out all in one go. Bang, done. Yeah, no mucking about. There it is. So much more compact and concise than what we're seeing over here with all these ridiculous Serial.print statements that drives everybody mad. Okay, what else can we do with printf then? So here we have a very similar printf statement here. Except that there's a few differences in some of the values we want to pop in there. So we're saying iteration %10i. So what do you think that does? Haha, yes, you're ahead of me. It means print the integer value that I'm going to tell you about, but I want it to occupy 10 character positions. Yeah, 10. Has a value of %.10 long integer. What do you think the 10? Yeah, okay. You can specify how big these things have got to look on the screen. And even the float value, look, remember it truncated that value at the end? We're saying, look, it's 6 characters in front of the decimal point and 10 decimal places overall. And there's our int, long and float value exactly as we had before. So let's have a look what this comes out as, shall we? There we are. So iteration space 42, so now it's taking up 10 spaces, has a value of 1 million with 3 leading zeros, because we've said in the code we want 10 digits here. Derived from, I'm going to have to make this window bigger now to accommodate all this. Derived from 3.141592, 496, I didn't type that in. We didn't type this value into the sketch here, did we? We said 13.1415926, and yet it's already garbled the end of that value because it's a float. Shouldn't use floats or doubles, okay? A double is just a double precision float. Do not use either. Use integers and only divide by 100 or 10 or 1,000 or whatever it is at the point where you need to display it. Internally, keep them as whole numbers. You will lose precision. Case in point, we've already lost precision, and all we've done is store it and display it. We've done nothing else. Terrible thing, floats. Terrible. But at least it shows that we can display more digits at the back there than what we had before, simply by in our code showing this here, 10 digits after the decimal point. Okay, well, we're getting there. We can see perhaps that there's certain flexibility now, part of the printf statement. We'll just do one more, and then I think we probably, I think you've got the message, haven't you, really? Okay, next one then. There's a little trick you can do with the width. If you say, I don't know how long I want to make this output, I'll do it programmatically. I'll pass a parameter in to tell you how long I want the value to be displayed, how wide. So on here we're saying the width of %*. The star dot says, I'm going to tell you that as the next parameter. Star dot integer depends on the next parameter. It certainly does. And we're saying here 8. I want 8 characters to be occupied here for this int value of 42. So let's have a look what that looks like on the output screen. And there it is. The width of blank 42 depends on the next parameter. It certainly does. So, and we've done that by, remember, by passing in this 8 as the very first parameter before the actual values to be displayed. So if you're tabulating some output perhaps in a screen and you want things to line up nicely, you can do it this way with a little bit of thought and programmatic values being passed in. Okay. Is there anything else we need to know? Well, hold your horses. Okay, if you're printing a boolean value out, hands up, if you say serial.print and then a boolean value, what do you get? Do you get true, false, or something else? Yeah, you at the back.
A number.
Exactly. You'll get a 0 or a 1, because true and false are just, well, they're defined in the Arduino speak and probably most other languages as mnemonics, yeah? High and low literally means 1 and 0. So if you print a boolean out, you'll get 0 for false and 1 for true. That sometimes isn't very useful when you're looking at debugging output and you're expecting something to say true or false and it comes out as a 1 or 0. Just not that great. This is how we can make it actually issue the word true or false. Of course, you can do this in Serial.print, but in Printf. So we're saying lies can never be %s. S stands for string. Yeah, we're talking really C++ string, but Arduino string works as well. Don't forget the new line at the back. The Boolean value that we're now interrogating, this is now an if statement. Look, the Boolean value, question mark. Is the Boolean value set? You could say Boolean value equals high or true. Do something, but we're saying, is the Boolean value set? If so, output true, else, output the word false. And this construct, this quick if statement, can be used anywhere you like in the C++ language as a quick if. Yeah? And if, do this, else do that. Yeah. So by doing this, we can actually output the Boolean value. That's how that looks on the serial monitor. There we are. Lies can never be true. Okay, one final thing. We said at the beginning, you always have to put this /n look on the end of all these outputs. /n here, /n here, see that? Because it will not put a new line on for you. If we look at this code here, we don't want new lines in this case. We're saying the meaning of life is, and then we want to continue our sentence. So we do not put the /n for a new line. And then we have a little bit of logic. In this case, it's, is the integer value 42, in which we print one statement. Otherwise, we print something entirely different. But look what happens on the screen, just to make the point very clear. We say the meaning of life is, and look where the cursor is flashing. The cursor is flashing after the space that I put in on the code, waiting for the next output. So we haven't put that /n in for the new line, so it's waiting. It's going to print it on the same line in the same way that Serial.print does. And then we come into the code and we say, well, if the integer value is 42, which we know of course is true, it's going to print a decimal value, %d, with a new line and the integer value of 42. Otherwise it would print a string called unknown. But of course we know what's going to happen. So if we just continue this, there we are. It prints 42 plus the new line. Pretty simple, isn't it, really? Now, there are probably a gazillion permutations of all this, and there are too many really for me to cover in this video, and it would be pointless, frankly. I just want you to get to grips with the basic ones that I've shown you here. The integers or decimals, floats, if you're going to use them. Please don't use floats. Strings, as we showed you there. Booleans, if you're going to output a boolean as a string. They will make your code so much clearer. If we just scroll back up this code and have a look at the beginning where we have all these statements to output that one line, iteration 42 has a value of 1,000,000 derived from, blah, yeah, all that. And if you can imagine, you're writing your code, have to put that in there. I mean, it just destroys the code, doesn't it? You've got all these big block of serial statements. I don't like it, don't use it. Well, I use ESP32 a lot of the time, and Printf, as I say, is built in there. But you can still use Serial.print if you want, but please don't use the Printf, and this will make it very easy. And once you've done it once, you'll think, why on earth didn't we always do this? Why didn't Arduino invent the Printf for Arduino instead of giving us Serial.print? Well, the Serial.print is very, very forgiving, yeah, and you can put pretty much anything after Serial.print. And so I can understand why they did it. But now you've moved on from that, haven't you? You've moved on. And I think the Printf construct like this is just going to be so much easier for everybody, to be quite honest. So, well, I'll leave you with some examples, but more importantly, you should really read the C++ page that I often go to, C++ site, and it tells you everything you ever need to know. It's a little bit geeky and techno, but once you cracked the table, I'll show you. So this is the C++ website, and I find it very good. It goes through an awful lot of stuff. You'll probably find other websites that are equally good, but anyway, this is the one I tend to choose. Now, Printf, it goes in the nth detail here about exactly what you can and can't do, but don't get put off by all these sort of output things that it's talking about here. Look at what I've done in my example videos and see which one of these character types, for example, you're trying to output, variable types I should say, and experiment a bit. If you write a little test sketch, you'll probably see exactly what works and what doesn't. I mean, for example, you can output in octal and hexadecimal. We haven't tried that. I mean, if you need it, you'll probably find out how to do it, won't you? And yeah, there's all flags and all sorts of stuff. Now, Printf, whilst being the ultimate in usefulness, I think, as far as C++ formatting a string to the output stream goes, there's also a couple of functions like sprintf. I'm not going to touch that here. I'm not going to touch it. If you need to know how to use it, you'll probably learn how to use it. Basically, if you can imagine you do a printf, that particular example that we had, where we're printing a particular string with all the variables dotted about inside it, but instead of putting it to the UART, the serial output stream, you say, no, I want to put that exactly as it is, all nicely formatted and everything, into a string. So perhaps I want to put that value on a web page or a report or something. Yeah, you can do that with snprint, or sprint. Snprint, okay, that's a variant where you say this is the maximum size of the string or the buffer that you're going to output. But already we're getting far too deep into the bowels of C++, I think, for Arduino beginners. Use printf first, see how it's used. Look at sprintf to see how you might use that if you ever need to, printing it into a buffer, a string, and then doing something with that string, and see how you get on. But printf is definitely the way forward to make your code cleaner and just more readable, basically. Okay, I think that's done now. I think all the debugging stuff in serial output, I think we've covered in some detail over the last few weeks. So I can only suggest that you try these things out. Don't just leave it languishing here. Just write a simple little sketch as I've done here. In fact, download the sketch that's in my GitHub onto your spare Arduino Uno and just see how it works. And once you've got it, you think this is fantastic. Best thing since sliced bread. What was the best thing before sliced bread? That's what I want to know. Anyway, don't forget, if you like the video, give it a thumbs up. Comments down below, please. I know there's going to be all you experienced people going, oh, you didn't mention this and you didn't. Yeah, okay. And yeah, don't forget to subscribe and tick the bell if you want to have notification of new videos. And yeah, I think we're done here. See you next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.